Good morning, friends. Today, initially we start with integrated feeder protection relay. Means the combination of all the feeder protection relays in one unit. That is numerical relay alinth for numerical relay alinth. What is the various relays in the feeder protection? That is over current relay 3. HB side is OCR 1, LB side is OCR 2 and feeder side is OCR 3. Then our delta I protection, then our differential distance protection relay, then wrong phase coupling relay, then PT fuse failure, and some are also pento flashover relay is there if insulated overlap is in front of the TSS, or where the neutral section is there in front of the TSS, there the pento flashover relay is not required. Here no pento flashover relay setting I have shown. So all has been given here. For impedance setting, you follow it, and if you cannot understand it, you tell me. The feeding jurisdiction is near about 130 km. It is a double line section, but they have taken single line impedance, that is 0.41, because better to take the higher one. So they have taken 0.1 ohm per kilometer. This is a double line impedance. Total line impedance, then they have found out 130 is the kilometer and impedance per kilometer is 0.41 ohm. So it is coming around 53 ohm. CT ratio has been taken 1500 by 5 ampere. PT ratio is 27.5 kV by 110 volt. CT ratio by PT ratio, how much it is coming? It is coming 1.2. Now forward reactance, XF, it is called XF. We are taking the parallelogram characteristics of impedance relay. Earlier there is a circle, there is a circle. Now it is shown in parallelogram where the forward reactance, backward reactance, forward resistance, backward resistance is given. So what is forward reactance? It is ZL, impedance of the load into multiplying factor into sign relay characteristics angle into CTR by PTR. Why it is? You try to understand it later. I will, in the next day I will discuss it, why it is coming, this formula is coming. Okay, so XF is how much? Our impedance found out is 53 ohm total impedance for single line, and multiplying factor is 25%, 1.25. Then sine relay characteristics angle is 70 degree, so sine 70 degree, and CT ratio by PT ratio how much? It is 1.2. So XF is coming 75.128 ohm. This multiplying factor is given for CTPT error, CTPT relay error. We are taking 25%. Okay. Then ZL, load impedance. It is relay characteristics angle is 70 degree, reverse reactance XB. It is taken 25% of XF. 25% of XF. So XB is 75.128 into 0.25, which is coming around 18.78 ohm. 18.78 ohm. But in Ashida relay, they have changed the system. Ashida relay later I will discuss. For Alinth relay, they are taking XB is 18.7, 25%, XB is equal to 25% of XF. Then forward resistance. The formula for forward resistance is ZPL, peak load impedance, it is peak load, is equal to 27 kV into CT ratio by PT ratio. Thereby 150% of transformer rated secondary current. It is 800 ampere. So they have taken 150 1.5. So it is coming around 27 ohm. Forward resistance is coming around 27 ohm. In order to accommodate the arc resistance of CTPT tolerance, Z is equal to 70% of ZPL. Then 27 into 0.7 is equal to 18.9 ohm. So forward resistance RF is equal to Z cos 36.9 degree minus sin 36.9 degree tan RC. These are all need calculation. I can show you later. Forward resistance is equal to 18.9. Then the value, it is coming around 10.98 ohm. 10.98 ohm. And this backward resistance, it is called reverse resistance. Let's see. The forward resistance and reverse resistance is same. Is taken in the Allen relay. So it is also how much we have seen it in the earlier slide. Next is overcurrent setting. Overcurrent setting. Instantaneous overcurrent relay setting. The feeder CB is instantaneous, means when there is a fault it will trip immediately. No time lag. It is not IDMT, inverse definite minimum. To permit the overload, we use IDMT in 132 kV size and 25 kV size transformer CV. But in feeder CV, it is instantaneous. Immediately it will trip. So we are taking 200%, means 800 is the rated load current of feeder side. So it is coming around 1600 amperes. Reflected to CT secondary side, we have to multiply it by the CT 1 by CT ratio, that is 5 by 1500 is equal to 5.333 amperes. It will go to the relay circuit. Percentage setting relay is 5.333 into 100 by 5 is equal to how much? 107% for relay setting. I have told you relay rated normal current is, relay secondary rated normal current is 5 ampere. So this 5.333, how many parts? This is how many parts? 1.06 parts. So multiply it with 100 for percentage, it is coming 106.66%. Wrong phase coupling, here we are simply keeping the low impedance 10 ohm and high impedance 40 ohm. It is keeping low and high, thus no calculation is required. And WBC low angle 100 and WBC high angle 150. Simply keep it in the Allen relay, so it will work. Then PT fuse failure protection. IP is equal to 0.75 225 amperes in feeder bus. BP is equal to 10 volt 5.0 in the feeder bus. These two settings you give, it will act. So friends, the feeder relay setting we have seen, integrated feeder protection relay. Now they have given in a data sheet all the settings which need calculation that also given here, and somewhere in the instruction manual they'll give how to set the other settings. No calculation, simply their guideline we have to follow. So it's almost over. Next time I'll discuss Alin Asida relay so that it will be clear. Almost both are same, but for feeder protection and distance protection relay, some changes are there for Asida relay. So be happy today up to this. Enjoy it. Okay.